The next type of addressing mode is index addressing. In our 8086 microprocessor consists of there are two types of index registers are available, that is SI and DI. So SI stands for source index and DI stands for destination index. So if any one of the register will be given in that source and destination operand, that time we are considering this addressing mode as the index addressing mode. Suppose I am considering this instruction that is move BL, SI. So you can consider here, this is our memory location and here the address is 2000H. And on that 2000H location, our value is stored that is 30. For example, our value of SI is 2000H. So what happens if the value of SI will be a 2000, then we can writing it here, SI is equal to 2000H and our instruction becomes move BL, in bracket SI. So we are considering this bracket here, that means effective address of our SI location. So we are writing here 2000. So whatever the contents are stored in that 2000H, that will be copied into our BL register. So in that 2000 location, the value is stored 30. So we are copying the contents of 30 into our BL register. Now you can check this second instruction, that is add bx, di plus 8. So again you can consider here this memory location, and in that memory location the address of the di is stored that is 8000H. Suppose this address is 8000 and here I am storing this address that is 8008. And on that 8008 location, what will be my value? Suppose I am storing here 35. And whenever you are writing this add ax, di plus 8, that time they are taking the value from that di register and our di consists of value that is 8000. Suppose you can consider here the di consists of 8000. So I am adding here 8000 plus 8. So it will become add x, in bracket 8008. So check here what is the value that is stored in that 8008 location, that is 35. So I am writing here add x, 35H. So after writing this instruction, your ax is equal to ax plus 35. So whatever the value will be there in that ax register, that will be added with 35 and the result will be stored in our ax register. So in that index addressing mode, what you have to check? You have to check this SI and DI will be there in our instruction. If the SI and DI register is there in our instruction, that time they are holding the index value of particular memory data. And it may be a signed 8-bit displacement or it may be unsigned 16-bit displacement will be available in that particular instruction. Same here, we are writing move ax, SI plus 5. Suppose consider that value of SI is 2000. So 2000 plus 5, this becomes 2005. And we have to check here what will be the contents of that 2005 location. Suppose in that 2005 location, our value is 45H. So this 45H will be copied into our AX register. So now our AX becomes 0045. So that is called as index addressing mode. The next type of addressing mode is base addressing mode. So here we are considering the base address of our 8086 microprocessor. So the base address registers are BX and BP. BP stands for base pointer. And these two are, both of them are 16-bit register. So whenever I am writing the instruction that is move ax, BP plus 2, so here the base pointer register is available. Out of that BX and BP, if any one of the register will be there in our instruction set, that time we are considering it as base addressing mode. So consider this example, our value of BP is 2000H. And now what you have to do, you have to check this instruction, that is move x, BP plus 2. So whenever I'm writing this instruction, that is move x, BP plus 2, that time you can consider it as move x, what will be the value of our base pointer, that is 2000, and plus 2 will be there. So I'm writing here move x, 2002. Now we have to check what will be the value of 2002 H memory location. So here in that 2002 memory location, the value is stored 36. And now we have to copy this content into our AL and our AH register. So here till 2003 H location will be there. So I'm writing here 2004 location, and this will be the 2005 location. And consider here the value will be 30, and here it will be 31. So whenever I'm writing this move x, BP plus 2, so we are adding here 2000 plus 2. So 2000 plus 2, it will become 2002. So whenever I'm considering this location, that is 2002, that time this base pointer value will be updated. And this base pointer value becomes 2002. And here we have to store the contents of AL is equal to BP plus 2. And here we have to store the value of BP plus 3 in our AL and AH register respectively. So the value of our base pointer will be 2000. So 2000 plus 2, that is on the 2002 memory location, the contents are 36. So our AL register will be 36 after executing this instruction. And now the next part is our base pointer is 2000. So 2000 plus 3, that is 2003. And on that location, the value is stored, that is 37. So 37 will be copied into our H register. So that is called as a base addressing mode. So here we have to check the BX and BP register. If any one of the register will be there, that is the base register will be there in our source operand or our destination operand, that time we are considering this addressing mode as base addressing mode. The next type of addressing mode is base index addressing mode. So in that we have to check the base register as well as index register. So our base registers are that is PX and PP. So these are the two base registers are available, and our index registers are SI and DI. So we have to check here if base and index registers are available in our instruction, then that time we are considering it as base index register. So here you can check move x, in bracket bx and si. So here we are combining this base register as well as our index register. So address of our memory location will be added there, and that data will be copied into our AX register. So the base register and the index register will be there in our instruction. That time we are considering it as base index addressing mode. The next type of addressing mode is relative base index addressing mode. That is also called as a base and index with displacement addressing mode. So here the base registers are also available, the index register is also available, and we are providing the displacement, that is the addressing mode will be there. So here you can check the instruction is move x, bx plus si plus 6. So 6 is the immediate value, bx is the base register, and si is the index register. So here in this type of instruction, the base registers are available, then the index registers are also available, and the immediate value is also available in our instruction. If the combination of these three will be available in that instruction set, that time we are considering the addressing mode is that the relative base index addressing mode.